germanium. Find the current through the diodes is asking. How they are connected? Parallel, no? So definitely this 20 volt, what it can do, this 20 volt, it can forward by this. And for the silicon diode to get forward bias, what should be the potential difference across it? Should the potential difference across it should be 0.7 volt. To forward by this, what should be the potential difference across it? 0.3 volt. But since they are parallel, so what will happen here? So in fact, this diode, what will happen, will be unbiased. Where this will be forward bias. So I'll replace with a 0.3 volt in place of germanium diode it is. Unbiased means as good as no current. Or shall I replace short circuit? What do you say, unbiased? What shall I do with the diode D1? I'll give name diode D1 and D2. Zero 0.3 volt is there. So then 0.3 volt, it will come for this. If 0.3 volt will be applied, what is the state of the diode? Very small current flows. Now, very small current means it's like open circuit. Is it a reverse bias? No, better call unbiased. There's a difference between reverse bias and unbiased, please. So overall current will pass through the diodes. So call I2. No current will flow through this diode. So calculate that I2 value. So what is I2? You can write 20 minus 0.3 by 5000. You'll get the current. Unbiased means as good as like a no current. No current means go back to current density, we'll put open circuit. That's the meaning. What would be the potential drop here? 0.3 volt again. And to forward bias minimum how much you need? 0.7. This I think when diodes are parallel, no, you have to be very careful. This is something. No, it asks questions, sir. Why can't this be 0.7 so that this voltage will be sufficient to forward by this? So you can also, a student can also just think in this way, like, sir, here let it be drop 0. Let this diode be forward bias. Then how much here? 0.7. Then 0.7 is sufficient for to forward by this. Why can't be like this? But what is the maximum possible drop across this diode? 0.3 volt, finish. More than that, not possible. So what is the maximum possible drop across the diode? Equal to its barrier potential. But sir, in the graph you have shown something, but the way the graph what you plotted, so here what will happen? Very small increment. If you see ideal, if you say, I think the books what happen there, they have given like this. So it's correct in fact. This one, so there's a knee voltage, no? So say 0.7. Here what will happen? It is just like 0.7001, 0.7002 of like this. Very small change in voltage, very large current will flow. What happens if more than 0.3 hours? Germanium cannot have more than 0.3, cannot obtain that. It is not current density. What will happen? If you go and practically connect voltmeter across a germanium diode, it will read 0.3 volt, finish over. It cannot possess. This is a germanium diode. Okay, fine. So I think in this region it's being operating. So we practically open, it will have small slope. Then what is this? This will be of order 0. Microvolt change will come. Means 4 3 decimal places when you